Okay, hello and welcome to another presentation, this time on vectors. We're going to be going through a few exam questions just to remind you of this topic and really just jumping at the deep end. Okay, so I've got two vectors here. This one I'm going to denote as A, and if you haven't got the luxury of using bold, you underline it like that. Sometimes with a curly underlining, I tend to go curly, but you can just do them straight. So we've got two vectors here, A and B, and we've got a point P. Now, we will answer the question at the bottom in a second, but let's just firstly write down what the vector A actually is as a column vector. A is clearly the vector. Well, we're going to go 2 across in the x and 0 across in the y direction. We're not going any way up. And so that's 2, 0. What about B? Well, B equals, we're going 3 across and 1 up here, so that will be 3, 1. And all of those are positive because we go to the right in the positive x direction and up in the positive y direction. Okay, let's see if we can now draw the vector PQ, bearing in mind PQ equals A plus 2B. Now if PQ is A plus 2B, then one way of looking at it is we can go across A, and then we can just put on the end of that 2 B's. So there's 1B, and let's do another B again because we need 2 of them, and there's 2 B's. And so here is where Q must be. And now what I wanted to point out is if you actually do A plus 2B, that's going to come to 2, 0 plus 2 times 3, 1, which is 6, 2, which comes to 8, 2. Now how does that relate? Oh, that's a frequent mistake actually. Don't put a line there underneath. That is definitely not correct. It's what I see my students doing all the time, always moan at them, and look at that, I've just done it myself. There are no lines like fractions in vectors. Now what does that 8, 2 mean? Well, sure enough, if I want to get from P to Q, I need to go 8 across and 2 up. So it's worked, if you see what I mean. I've just moved it slightly out of place. There we go, that's better. It's worked. A plus 2B is the vector PQ. Let's have a look at another kind of question. Okay, these kind of questions are quite common. They are essentially vector geometry. Nothing like the kind of vectors that they do at A level either. Now we're told PQRS is a trapezium, which immediately means that, as it points out itself, QP is parallel to RS. Now the rules with parallel vectors are that they are simply scalar multiples. What do I mean by scalar multiples? I just mean one is a scale factor enlargement of the other, if you like, but they're in exactly the same direction. That should help us, together with this fact here, that QP is 3RS. That should help me to establish what QP is in terms of C, because since QP is parallel to RS but 3 times longer than it, it's just going to be 3C. Now this is the important thing about vectors. Vectors don't have a start point or an end point in a sense. They are floating in free space. We can pick that RS up and put it on QP, and we'll need 3 of them end to end to make QP. SP is a little bit more difficult, if you like, but I always encourage my students to find a route, a way of getting from S to P. Now, as we already know that this bottom vector is 3C, we've got a way of getting from S to P, because S to P is the same as S to R plus R to Q plus Q to P. That gives me S to R is going to be minus C because I'm going backwards along the line. R to Q is going to be minus A because once again I'm going from backwards down the line. So let's put a little minus in there. And then lastly Q to P is going to be plus positive 3C because that's going in the right direction. All we've got to do now is simplify that and you get 2C minus A. And the question's done. Now, I always like to point out to my students that if I start from S and I go 2 C's across, there's 1 C, and this is going to take me slightly off the screen, but I'm going to do it anyway just for the purpose of showing you. There's 2 C's, and then I put on the end of that a minus A. Now look at that other A across, it should be parallel to it but going in the wrong direction, just like I've drawn it. Sure enough, that 2C minus A does take us from S to P if you put them in strings going along, because basically if you add 2 vectors you just put one vector on the end of the other vector and it tells you the resultant vector, which is what we did in the first question. Okay, let's take a look at question 5 now, because this is really quite a tricky one, or at least it can be tricky, and it's actually not too bad. Now, we've got a triangle, it's quite a typical question this, and we've got a point P so that it's divided up in the ratio of 2 to 1. So AP is twice as long as PB. Okay, now the question is asking for the vector OP in terms of A and B. Now I would always say in these kind of questions that if you want to find OP, you better find AB first. AB and then AP. Now AB is quite easy to find, because we're just looking for a way of getting from A to B using the little vectors, little a and little b. And that will be clearly minus A plus B, because we need to go back from A to O and then up from O to B. So if I now want AP, well AP is clearly 2/3 of AB, because it's split in the ratio of 2 to 1. So I'm just going to need to find 2/3 of the above result, and that gives me, if you like to multiply out brackets, minus 2/3 A plus 2/3 B. Okay, we're now getting very close to the answer, because OP, to go from O to P, I need to get from O to A and then add on the end of that A to P. Well, that's good news, because I've already worked out AP and OA is simply A, so I've just got A plus negative 2/3 A plus 2/3 B simplify that and you get 1/3 A plus 2/3 B, and that is the final answer. They might factorise the third out, I probably would, so if I did factorise the third out I would have 1/3 A plus 2B. And we're done, and it's a nice tidy answer. Okay, the very last question I wanted to do involves, in the last part anyway, proving that 3 points are collinear or lie on a straight line, as you might put it. Now, the question starts off similar to last time, similar to the very last question we did. We've got to find OP first, and once again, best way to do that would be to find AC first, then AP, then OP. So AC first. Well, if I want to get from A to C, I need to do minus 6A, and then I need to add on 6C. Now for AP, as the ratio, well, as it says it right up here, as AP is 2/3 of AC, I can just do 2/3 of that, so AP is going to be equal to minus 4A plus 4C, because that's 2/3 of 6. And now I'm in a position to find OP. OP is simply OA plus AP. Giving us 6A minus 4A plus 4c, and we end up with an answer of 2a plus 4c. Okay, let's get on to the interesting part of the question though. The interesting part of the question is the next part, where it says CB, the midpoint of CB is M. Prove that OP and M lie on a straight line. Okay, so let's first put M on here and find the vector OM. OM is simply going to be 6C, OC in other words, plus half of OA because they're parallel, and so plus 3A. Now, how do we prove points lie on a straight line? Well, if we can demonstrate that OP is parallel to OM, because they've got a point in common, that's sufficient to deduce that they're on a straight line. So all I have to do is say, well, OP is, I'm going to write it down in a slightly different order, 4C plus 2A. Therefore, OP is parallel to PM. Or to OM, sorry. Now, why is it definitely parallel? Because they are scalar multiples. All I've got to do is times OP by 1.5 and I get OM. OP is parallel to OM. And I'm just going to put in brackets scalar multiples to argue that case. So I've proved they're definitely parallel. All I really need to complete my proof that they are on a straight line is simply this argument. Since they have a point in common, the point in common is of course O. Since they have a point in common, they must be parallel.